So this first one, I want it to be, so there needs to be some outside function, some inside function. So this capital G is some inside function, and then we're multiplying by some other function. So if I look at this one here, it looks to me like an inside function might be this 3x squared. And then the outside function could be this e to the x. And then you're multiplying by some other function, this 6x. So to me, I'm seeing it look like this. It looks like equals 6x times e to the 3x squared. So in other words, I'm seeing this here as my big G, this here as my little f, and this here as my little g. So let me write that all out. So big G of x equals 3x squared. F of x is e to the x, because it looks like that 3x squared is plugged in for x and little f. And then my little g is 6x. Okay. So for this one, it looks to me like the inside function is this. And then my f is the outside function associated with that. And then you're multiplying it by this function g here. Now since it's on bottom, I'm going to write a 1 on top and kind of circle this whole thing as my g. So in other words, let me rewrite this. I'm seeing this as f of x is equal to, I'll write it this way, sine of square root of x times negative 1 over 2 square root of x. So I'm seeing this here as that inside capital G, this whole thing here as the little f, right? And then the little g part here is this. So let me write that out. So the capital G of x is square root of x. The f of x is sine x, because that square root of x is plugged in for x into sine x. And then the thing we're multiplying by, little g, is negative 1 over 2 square root of x. Okay. So once you kind of identify what the inside function is, the capital G, then the rest kind of falls out from there. Okay, so number 8 says I want to find a power function through those 2 points. So in other words, I can make 2 equations, one with that set of points and one with that set of points, and then I can solve for k and p. So, all right, let's just plug those in then. So if I plug in the 2 and the negative 1.6, I'm going to get, so that 2 is an x value, and the negative 1.6 is a y. So I get negative 1.6 equals k times 2 to the p. And then if I plug in the other set of points, I get negative 12.8 is equal to k times 4 to the p. Okay. And so the first thing, so let's see, how do we want to do this? So I guess we can solve one of them for k. So let's take this one and solve it for k, and then we can plug it into the other. So I get, so if I divide that by 2 to the p, I'll have negative 1.6 over 2 to the p equals k. And then I can plug that in for k in the blue function. So I get negative 12.8 equals negative 1.6 over 2 to the p times 4 to the p. Okay, and so now I can see, let's see here, how do I want to do this? I want to solve for p. So this is, you could see that as negative 12.8 is equal to negative 1.6, and then I have 4 over 2 to the p, because that 2 to the p is on the bottom. Okay, so now I think I can solve this for p. So I'm going to divide both sides by negative 1.6, and I get 8 when I do that. If I divide that over, negative 12.8 divided by negative 1.6 is 8. And then 4 divided by 2 is just 2 to the p. And so then I can, well, I guess I know the answer at this point. I know the answer is p equals 3. Okay, and so if I didn't know, I could take the natural log of both sides and solve for p, but anyhow, I can see the answer sitting there. So then I know that my k is equal to negative 1.6 over 2 cubed. So if I do negative 1.6 divided by 8, I get negative 0.2, so that's my k. So here's my function. F of x is equal to negative 0.2 times x to the third. Okay. Then one of Kepler's 3 laws states that the square of the period of a body orbiting the sun is proportional to the cube of its distance from the sun. Okay, so let's write that down there. So I know. So what that means is that the square of the period, p, so that's p squared, is equal to, is proportional to, so that's k times the cube of its distance from the sun, so d cubed. Okay. And then it gives us, this is a value of p, period is 365 days, and then that is my distance, so that's a value of d. So I can use that to find my k. So we get 365 squared is equal to k times, good gracious, 93 million cubed. All right, so this is going to end up being in like scientific notation, so that's fine. We can do this. 365 squared divided by 93 million cubed. So I get, oh Lord, okay, k equals, okay, it looks like 1.656 times 10 to the negative 19th. Okay. And then, all right, so then p as a function of d is p is equal to, well, p squared is equal to that, so p is equal to the square root of that, 1.65 times 10 to the negative 19 d cubed. Okay, so that's what p is in terms of d. So that's the answer to A. Okay, does that make sense? And then the planet Jupiter has an average distance of that. How long are its Earth days as a Jupiter? How long in Earth days is a Jupiter year? Oh, the period. Okay, so the period P must be measured in Earth days. Okay, all right. So we just are plugging in that distance and seeing what our P is in Earth days. Square root of 1.65 times 10 to the negative 19th, and then that D is 483 cubed. Okay, so let's type that into our calculator. Square root of times 483 cubed. I got P equals 4,311.8, so maybe we round up. And yeah, I mean, I kind of stopped at 2 decimal places. Maybe I could have been more exact there, but anyway, so depending on how many decimal places you use here, that might change that number slightly, but anyway, it should be in that ballpark. So this is Earth days. Okay. All right. So the next one, I want to find that limit as x goes to infinity. Okay, and so I can think about this, I can think about this graphically, and I think about that is a, okay, just a second. That is a cubic, but it's an upside down cubic, right? And so the end behavior of that one is going to be like this and like that, right? So the end behavior as x goes to infinity is going to be negative infinity there. So a positive odd degree polynomial will look like this in its end behavior. A negative odd degree will be flipped over, so it will go like this. And that's what we're dealing with here, because it's an odd degree and it has a negative coefficient in the front. A positive even degree will have end behavior like this, kind of like an x squared, and a negative even degree will be, you know, like an upside down parabola, kind of going like that, something like that. So that's kind of the end behavior of these, so you can think about that. All right, so next, it says find each of the following for the polynomial. Okay, so I have this polynomial here. All right, so the degree, okay, so I have a quadratic multiplied by a cubic. So the highest degree is going to be 2 plus 3. So the highest degree is 5. And the zeros are negative 4 with multiplicity 3. And what, let's see, do I get any zeros out of this thing? Let's use the quadratic formula and see. X equals 9 plus or minus the square root of 81 minus 4 times 2 times 7 over 4. What is that? 81 minus 4 times 2 times 7 is 25. 81, 4 times 2 times 7. Oh, okay, so that's square, so that's 9 plus or minus square root of 25, that's 5, over 4. So that gives us what? 9/4 plus or minus 5/4? 9/4 plus 5/4 is 3.5. And then we also have 3.5. And then 9/4 minus 5/4 is 1. Okay, so those are the zeros. So we have negative 4 with multiplicity 3, 3.5, and 1. So those are our zeros. And then as x goes to infinity, well, I guess we could have factored that maybe. So if we had 2x, x, so x minus 1, x minus 7. Yeah, that works. So x is equal to 7/2 and 1. So those are our zeros. That one, and that one. Okay. As x goes to infinity, f of x goes to, well, it's an odd-powered function, and the first leading coefficient is positive, so we're in this case up here. So that goes to infinity. And as x goes to negative infinity, if we travel backwards, f of x goes to negative infinity. Okay. Short run behavior polynomials. Polynomial of degree 4 is shown with that. We want to find a polynomial of degree 4 with those properties. Okay, so the zeros are 2, negative 2, 1, and 4. Okay, it needs to be a polynomial of degree 4 as shown. Oh, I see. So we can see that at negative 2 it has even multiplicity. So x plus 2 is going to show up twice as a factor. At 1 it crosses, so it has an odd multiplicity, so it must be first degree, because we only have 4 factors here we can deal with. And f of 4, again, it crosses, so that's an odd multiplicity. So x minus 4, and then we have some a in front, we don't know. All right, and what I need to happen is I need that when I plug in 0, I get 4. So let's see what happens when we plug in 0. I get 2 times negative 1 times negative 4. And that needs to be equal to 4. 2 times 4 is 16. So we get 16a equals 4. I can divide that over. I get 1/4. Okay, so my polynomial is f of x equals 1/4 x plus 2, or I could write x plus 2 quantity squared if you want, x minus 1, x minus 4. All right, last one. Use long division to determine if x minus 6 is a factor. If it is, factor it the rest of the way. Okay, long division. So this will be fun. Let's delete all of this stuff so I can see. Okay. So I want to set it up like this. So I have x cubed minus x squared minus 29x minus 6. Okay, and I want to divide out of that x minus 6. Okay, so the first thing I want to do is I want to say how many times do I need to, what do I need to multiply x by to get x cubed? And the answer is x squared. And then when I multiply x squared by each of those guys, I'm going to get x cubed minus 6x squared. And then I want to subtract that from the thing I have above. So x cubed minus x cubed is 0. X squared plus 6x squared is, or sorry, negative x squared plus 6x squared is 5x squared. And then I'll drop down the minus 29x. All right, now what I want to do is I want to see what do I need to multiply x by to get 5x squared. And the answer to that is I need to multiply x by 5x. Okay, and then I'm going to distribute this 5x across these two terms. And when I do that, I get 5x squared minus 30x. And then I want to subtract those guys. So I get 0x squared, and then negative 29x plus 30x is going to be just an x minus 6. And what do you know? That's what I need. So if I do plus 1 here, and I distribute that 1 across those two things, I'll get an x minus 6. And when I subtract that, I get a remainder of 0. So what does that mean? That means that it was a factor. In other words, that means that x cubed minus x squared minus 29x minus 6 could be factored as x minus 6 times the quadratic x squared plus 5x plus 1. And so now this guy here is a quadratic, and it doesn't look like it'll factor just off the top of my head, so let's see if we can use the quadratic formula to find the values of x. So x equals negative 5 plus or minus the square root of 25 minus 4 times 1 times 1. all over 2 times 1. So I get 5. So I get negative 5. So x equals negative 5 plus or minus the square root of 21 over 2. So those are the other two zeros. So the zeros of h are positive 6 and negative 5 plus the square root of 21 over 2 and negative 5 minus the square root of 21 over 2. So those are my zeros that I have there.